Welcome everyone to How Concurrent Systems Engineering Can Help Your Organization, presented by Mark Malinoski. My name is Donna Long and I will be your host during today's webinar. Mark is a technology and business manager with more than 30 years of experience in engineering, marketing, and general management. His expertise is the development and launch of leading-edge technology products to global market segments. Mark has been part of high-tech production and metrology equipment firms such as Schlumberger, JDS Uniphase, Advantest, and Tektronix, and has spent 10 years as an independent consultant. As a technologist, Mark holds 6 patents and has been published in major technology forums. Before Mark gets started, I have just a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Mark will answer as many questions as he can today, but if he does not get your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be made available within 1 business day. The recording will be published to Vitek's webinar archive, located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you would like to see covered in future webinars. Now I'm going to turn the presentation over. Welcome, and thank you for joining us.
Thank you, Donna, and thanks everyone for making the time available. As Donna mentioned, we're going to be describing today how achieving MBSE 2.0 performance in your organization will achieve concurrency in your systems engineering. If you've participated or been following the messages and content that has been provided by Vitek of late, assessing the state of the art of industry and systems engineering, you'll have heard us refer to something called MBSE 2.0. And MBSE 2.0 embodies a much more concurrent and connected form of engineering of systems. As complexity continues to increase and product cycles continue to shorten, the need to embrace the initiatives around digital engineering are driving us to have much more enterprise-wide engagement with systems engineering and the resulting system architecture. So where previously the bulk of systems engineering was occurring in the very front end of a product or enterprise architecture cycle, now those artifacts need to be much more alive and enabled for downstream participants and performers to interact with. To be able to achieve this kind of concurrent and connected form of engineering of systems, we need to have a common information model or a common way to describe, decompose, and express system design and architecture. So the foundation of achieving MBSE 2.0 is what we call the systems-metamodel. Now, the systems-metamodel is a collection of concepts and classes of information that we use to describe, decompose, and design systems. A metamodel, by definition, is a model of a model. A systems metamodel is a specific type of metamodel that is able to model the models of systems. Now, this systems metamodel has been around for many decades. We can trace its roots back to the early days of TRW engaging with the Department of Defense and some work with NASA on the Apollo mission. And since then, it has been adopted by Vitek first when the first version of the core MBSE software package was introduced back in 1992. Since then, it's continually been enhanced, and now it's the underpinning systems meta model for our current generation of MBSE software called Genesis. A systems meta model needs to be industry proven to be able to describe systems of all types. It needs to be expressed in a natural language as opposed to something that's much more syntactic in nature and is not something that those that aren't skilled in the art of systems engineering are blocked from interacting with because of that cryptic syntax. It also needs to connect the enterprise in that it needs to be a design data that's able to be housed in project repositories of enterprise class databases. And in that way, many types of interaction with the project repository and the system designs and architecture becomes available across the enterprise. Now, understanding that foundational element called the systems meta model and how it can enable us to achieve concurrent connected engineering of systems, we'll start to realize commonality of practice. And commonality of practice is one of the goals that many organizations have failed to achieve. The state of the art of systems engineering has been relying on much more diagram-based ways to communicate across the enterprise. And in the design and production of those diagram artifacts, the commonality of practice has not been realized to the level that's going to reach across the enterprise in a very concurrent and connected way. But with a systems meta model guiding the design and architecture of systems, we can start to realize much more consistency of design data, which is going to give us more reusability, which is going to accelerate organizational learning and the ongoing adoption and journey of systems engineering overall. So systems meta model is a foundational element for us to be able to achieve MBSE 2.0 performance in our enterprises. So we're going to focus today on how this systems meta model can guide the design and architecture of a system in a very, I would say, an ultra simplistic way so that we can really see the systems meta model at work. Now, when we have the design following a systems meta model and all of the design data housed in a database, what we can do is choose the way that we're going to view the design data and architecture. Now, we've produced a cube analogy to this where you can envision all of the design data to be inside the cube, and then you would choose your view or representation of that design data based on what side of the cube you choose to observe the design data with. Now, there's a link under here up on the YouTube that you can view and see an explanation of this as well. But here we can see that we have the option of choosing to view the design data, for example, from a requirements management standpoint, and we can look at a conformant requirements diagram. And in the requirements diagram, we see our source level requirements and our derived requirements and how components are specified, how requirements are verified, and additional detail can be observed through this view and representation. Or we might choose to look at a much more physical context of the design, and here we see a block definition conformant diagram, and we would break down from the system level context the different components that comprise the system. We could choose to look more into the behavior of the system, and here we see a sequence diagram that would describe that, or an activity diagram that would describe the behavior of the system. Again, we're choosing the view or representation we want of the system, and the tool then generates these diagrams for us. We may also want to use the behavioral information that's in the design to go ahead and simulate that behavior and start to understand the parameter space and identify logic locks that might occur and block proper execution of the system. Now, if we were going to say, where would I start this MBSE 2.0 effort applying this systems model underpinned approach? The biggest return on investment of MBSE efforts usually can be attributed to attacking the interfaces. So the systems-metamodel describes a way to model interfaces in a very explicit fashion, as is all of the relationships in the systems-metamodel. So here we can see that if we picked any two components of an as-is system and start to describe how they would interact with each other, we could say, okay, I have component A on the top left and component B on the top right, and I know that they interact in some way, so I'm going to establish an interface between them. So my relationships between the component and that interface are the component is joined to the interface, and the interface can also include additional detailed layers of description of the interface, and so that I can refine each interface with additional layers of detail of the interface. I know that components perform some functions, so I can describe that by instantiating a function and then allocating it to the component. So I can say that that function is allocated to that component, or that the component performs that function. Functions also can be decomposed by other functions. So you see how the systems metamodel explicitly defines what the relationships can be based on the class of information of that bit of the system design. So we're going to actually get into how we would understand what does my components talk to and what do my components do as we might build out a system design. So attacking the interfaces is oftentimes a great place to start in understanding system behavior and designing from what we know about our systems to what we know less about and need more detail and illumination about. So here is another view of the systems metamodel, and I'm going to continue this discussion by walking around the metamodel and then illustrating different aspects of how our Genesis software uses the systems model to guide the practice of systems engineering and achieve a much more consistent way of describing the system and generating the different views and representations that the organization can more effectively apply. So I'm going to do that by going into Genesis, and what I'm going to do is I'm going to start a brand new project, and I'm going to call this Project Demo. So when Genesis creates this project, we're going to see that it has already created some instances of some of the classes of information. You can see that here in the Project Explorer, I have a list of some of the essential classes, and in those essential classes I have a component that's been created, a function that's been created, and a state that's been created, indicated by the folder being shaded in saying something's in there. So if I go and look into the component folder, I see that I have a system context component already created. Now where that came from is because Genesis understands the systems metamodel, it has the ability to automate some of the more labor-intensive steps that we would need to go through in building out our system design. So in this case, some of those capabilities of the model assistant has been, when you create a new project, you'll get the top layer component or system context, as well as a function which is associated with that system context component. So you can see that this initial function, perform whatever this system does, has already been allocated to the component system context. So now let's go look at that component system context, and you can see that that component has already been related to the perform system context function with the performs relationship. So in that way, Genesis can maintain the consistency and integrity of the design by assuring that the explicit relationships are applied as required by the systems-metamodel. So let's now go in and do a few things with our new project. So what we're going to do is we're going to open up a view on this top layer component in our system, and we're going to look at it with the block definition diagram. So now I have a block definition diagram of my one component, and I'm going to start describing some system. And I know that that system that I'm describing has at least two major subcomponents or subsystems in it. So in my block definition diagram, I'm just going to go ahead and drop a couple of new parts onto the system context. So now I have these two new components in my system. And you can see over here that, again, Genesis Model Assistant has already created functions associated with those two components that I just created. And if I go and look at those two components I just created, you can see that they have been related back to the system context with the built-in relationship here down in the lower part of my attributes page. Now, if I go back to my block definition diagram, you can see that I still haven't really established anything that these two components do with each other. So I'll close that and go back to my system context, and this time I'm going to open the view for the internal block diagram. And here's my two components that I created as I look inside system context, but there's still no interaction between them. So I can select these two and then say I want to connect those two nodes, and Genesis says, well, if you want to connect those, you need an interface, and you don't have any interfaces. So I said, well, I need to create a new one, so I'm going to create interface 001. So now I've created that, and you can see that in my internal block diagram, I've got this interface component 01/component 02, which that's just the default name Genesis has applied to it. I'm going to leave it just continuously default to these names just to simplify our process here. And if we go and look at that interface now, we can see that Genesis has assigned the joins relationship from that interface to component 01 and to component 02. And if I look at my components, you can see that I've got the joined to relationship established between the component and the interface. So the bidirectionality of those explicit relationships is always maintained every time one of them is asserted between any origin and target class. Okay, so that was interesting. Now let's go and do something in more of a behavior fashion. So I'm going to go into my perform system context function, and I'm going to open up a an activity diagram. So here's my not too exciting activity diagram, and I can see that I really haven't described any activity yet. So what I'll do is I'm going to go over here and say I'm going to put an entity on this activity diagram, and I'll start with dropping component 001, a function associated with performing component 001's function. And so now there's that function is on that activity diagram. And I will go ahead and drop another one on here, and that will be component 002's function. So there's a bit more interesting activity diagram, and now what I can do is I can say that I want something to be output by component 001's function. So I want to, if I want to create a new output from component 001, I can drag it over there, and Genesis says, okay, well, I'm going to go ahead and create an item for you, and that's going to be the output from that function. And if now when I go over here and if I broaden out my essentials folder a bit, I can see that I have this item created, which is being output from the function perform the component 001 function. Now I also want to have that be an input to component 002. So now I've got both an input and an output to relationship for item 1, and if I go back to my activity diagram, you can see that I now have item 001 associated with as being an output from component 1's function and an input to component 2's function. So here we see the activity diagram, that relationship is being decorated by the optional decoration, and that's conformant to the activity diagram standard in SysML version 1.5. Now, if I wanted to, that's great if I need SysML conformant diagrams, but perhaps I have some other behavioral style of diagram that I'd like to use, and so I can go back to my functions, and I can open up I'm going to open up the enhanced functional flow block diagram, and now I've got I have both the EFFBD as well as the activity diagram have both been generated automatically by Genesis for this particular design. I'll go ahead and turn the layout on my activity diagram so that you can see horizontal alignment of both. Now, so whichever one you're familiar with, they're conveying the same information, but you can see in an EFFBD, I don't decorate my connectors. It's a different representation than the optional decoration here in the activity diagram. So let's go ahead and modify this output path that item 001 is on so that it's actually going to be not a data input but a control trigger. So I'm going to go and I'm going to do that this time by going back into my Project Explorer, looking at my item 001, and I'm going to actually remove this input to the component 002 function. So I'm just going to remove that target, and then I'm going to introduce the trigger relationship to component 002. Now let's go back and see how that affected our diagrams. So I go back and I see my EFFBD. My item has now been changed to green to indicate that it's a control, as part of the control structure, and I can see this, that my connector has now a double-headed arrow on it. Whereas in the activity diagram, I still have a single-headed arrow. That's the proper syntax for the activity diagram, and the optional decorator has now been removed. So as you've observed this project being created, you see fairly fluid interaction between diagrams and the more forms-based style of interface that Genesis provides on a per entity basis. And that again is highlighting this. I can view and manipulate my data from a multitude of representations and views on it, both from the standpoint of modifying and observing the results, with all the different views being kept in synchronization. So I don't ever have the problem of I changed one diagram and I have to go manually adjust another diagram to keep it in sync. It's fundamental in a systems metamodel underpinned workflow that you engineer the design data and then you choose your representations of that design data so that they're always guaranteed to be synchronized. Okay, so we've done a bit of physical modeling of this simple two-component system. We did a little bit of behavioral modeling, and now let's continue our as-is design process and back into some requirements. So what I'm going to do is I'm going to go and open up a requirements diagram, and I'm going to see that. Let's start by creating a system context requirement. Let's do it that way. So I'm going to go in here and I'm going to say, let's say syscon REQ, just to give it a name. And in this requirement I just created, I'm going to type a description in here. So I'm going to say that the system shall trigger component 02 with an item output from component 001. Okay, now so I've got my requirement. And now what I'm going to do is I'm going to add a refine by requirement to this. So I can add some, let's do that. Now that I have a requirement, I'm going to go ahead and open up a requirements diagram for this guy. So I'll go find my requirements diagram. And now what I can do is I can start to add some new requirements to this guy. So here I'll go and drop a requirement on him, and that gives me requirement 001. And let me do that again just to get a second requirement. And what I'm going to do is then I'm going to associate these guys with a with some of the components that we've already created in here. So if I go and find my refined by, well, let's see, I'm going to go and go to my go back to my components here, and now that I've got some requirements that I can actually have them specified by. So if I go look at my, I said I was going to do this for you, and I didn't get back to it yet. So here I can see I've got this component here, and I'm going to follow the specified by relationship for this requirement. So what we've done up until this point is we've got some components that have been performing some functions, and now what we're going to do is establish a path, a relationship between these requirements that are specifying these components or the components that are specified by those requirements. So let's go back to Genesis, and here we have component that is specified by, and Genesis pops up and says, well, what requirement would you like to be specifying it by? So I'm going to specify this component by requirement 001. And then likewise for component 02, I'm going to go and do a specified by relationship to requirement 02. So now I have in my requirements diagram, if I go back to my requirements diagram on my system context level requirement, we can see that now we're starting to build out this requirements hierarchy. So I've got these refined by requirements associated with my top level system requirement, and I've got these specified by relationships underneath here that establish the how these requirements are specifying these components. So now as I go through and again start to prefer to use maybe some other views, if I look at this particular view with a hierarchy diagram and my verification tree, I can see that my again, as we've seen before, the different views are being kept in synchronization in that these requirements are refining that top level requirement. And I can also see these in a type of spider view if that be my preferred way of viewing that. So now that I have some requirements built out for this system, let me go and start to do some work on verification. So I'm going to do that by going back to my requirements diagram, and I'm going to start to add some verification paths to my requirements hierarchy. So if I take this, and typically the way we would recommend verification to start to be built out is you'd start by making a one-to-one relationship between your verification requirements and your leaf level derived requirements. And so I've established a verification requirement there for requirement 01. I'll go ahead and do the same for requirement 02, and you can start to see how the verification architecture is starting to be built out. So if I go back to the systems meta model again, you can see there's quite a bit of emphasis been put in the systems meta model on test architecture and verification architecture. So I've now put a verified by relationship between my requirement and my verification requirement. And what I'm going to do next is start to establish how that verification requirement is going to be fulfilled and executed. So the systems meta model gives us the verification event, and you can look at this more like a part of a work breakdown structure in your project plan for doing your test and verification and validation. And naturally, that verification event needs to employ some test capacity, test configuration, a test bench. So we use the employees relationship to establish what that test configuration is, as well as the procedure that is going to be followed to perform that test or verification. Now, our verification requirements are also associated with an activity, and this is very much similar to a function, but it's specific to the activity that's going to execute that verification requirement. So let's go back into Genesis and see how Genesis enables us to do that. So here I have, if I look into where I've gotten my verification requirements that have been established, you can see that verification requirement 01 has, in fact, that verifies relationship with requirement 001. And now what I'm going to do is go, as I indicated, and start to fill out the the executed by portion. So it's executed by some test activity. I haven't created any test activities yet, so Genesis is prompting me for that. So I create test activity 001, and there I have my executed by relationship established. And I can also go and use this this approach to continue to fill out my my test configuration and my test procedure as well. So that's the approach we use to build out that the verification tree. So I want to make sure I leave some time for any questions. So I'm going to jump ahead and speak to a bit about how we do certain things in Genesis to help connect the enterprise and where the capabilities in Genesis are available to do that. So I jump over to the utilities folder, and I can see something called Team View. And inside the Team View, I can specify all types of detail of how I'm going to provide the HTML representation of the HTML representation. And once I generate this HTML representation, I can check this into a PLM system. I can do this as part of a baselining. I'm able to engage the all parts of the organization with this HTML representation. So here's what TeamView looks like. This is just a standard HTML browser looking into the data that was generated. So all of my data that we have been building through this project we created are available in a very similar fashion through this generated HTML. So you can see my block definition diagram. So you can see my internal block diagrams of my two interfaces. I can look at my the requirements diagrams that I had been. I can look at property sheets, etc. So everything that's been underway while I've been building out this system, I'm able to look at in a very similar fashion with my HTML views on the data. Another way, excuse me, another way that we can connect the enterprise is using the Genesis Excel connector, and I'll explain that next. So when I install the Excel connector on my system, I have the ability to directly connect Excel to Genesis. So once the Excel connector is installed, I see that I have this Genesis tab on my system. Now, when I open the Genesis tab, I can log into Genesis with the exact same credentials I would use to log into Genesis itself. And those credentials can be specific to the Genesis application. They can be Windows, your Windows credentials. They can be any of the enterprise level user credential directory systems. So now I've logged into Genesis, and I now have I can view my project repository, and I can see my project demo. Now the way the Excel connector enables us to view and modify data is through these table definitions. And the table definitions are, we provide you a number of them by default, and then you can enhance those or define your own. So let's look at requirements traceability, and you can see that the table definition for requirements traceability has the different types, data definition, what it's based on, and how I'm going to populate the spreadsheet. So you can edit this and save it off as your own version, or you can make completely different types of tables in this approach. So I'm going to go ahead and load this into my spreadsheet here, and you can see here's my my three requirements. I've got my system level requirement, and I've got requirement 001 and 002, and those guys have been they're specifying the component 1 and 2, and they're verified by verification requirement 1 and 2. Exactly what we had put into our system design. Now here, if I go ahead and say someone changed this on the webinar and click out of that, you can see that now it's been highlighted in the Excel connector saying, oh, okay, so something has changed here. So I go back into Genesis and leave the Excel connector open on the right. I'll go back to my requirements, and here's that requirement associated over there. So when I publish out these changes, then I can see, it immediately updates inside of Genesis. So Genesis itself really doesn't know whether this was another Genesis client that made that change, or the Excel connector that made that change, or some custom API that made that change. And then if I go and look into my requirements view here, and if I roll over that my system context requirement view, and you can see that the change has been made on that diagram as well. So again, underscoring that all of the information associated with this system design is 100% in the data that's in the repository, and all the different views and representations are based on that. So everything is always kept in sync. So if we jump back to our systems meta model here and just review quickly what we did, we started with a couple of as-is. We started with an as-is system and modeled out two components. We described an interface with a join-to relationship. We showed how these two components were built in the system context component. Then we created some simple functions to move an item around, and used it as both as an input and output in a triggering function. We then established some requirements and specified some components, and then we went about building out some verification capability for our system. And every step of the way, these explicit relationships define exactly how the originating class and the target class are bidirectionally tied together in the system design. And in that, you can see how you get the commonality of practice that we're looking for to be able to achieve the reusability of design data and accelerated learning of the organization. So just a little bit to close on where this systems meta model came from. As I mentioned earlier, there's a number of different evolution paths going on in the industry right now around systems engineering, some of which have been more data-driven, some of which have been more diagram or representation-driven. The systems meta model that Vitek has adopted is progressing, as I said, from these early days of TRW involving with the military and NASA, and has progressed to the point that we've gone ahead and expanded it to be able to express DODAF diagrams and also all of the SysML version 1.5 representations. And other things have in the industry, in a less connected way, but still significant in terms of data representations, have been occurring as well. And now all of this is feeding into trying to realize some type of MBSE 2.0 enabling systems meta model standard. We're not there yet as an industry. but we're encouraged by some of the work that's going on and how there seems to be convergence to realize that. Now, SysML has been a powerful force in the industry in terms of driving more diagram representation based system designs, and now SysML v2 is in the works. Vitek's heavily involved in that. We're trying to inform SysML v2 as much as possible. We're really enthused by a lot of the technology that's being brought to bear to implement SysML v2, and we're hoping that we can realize a common systems meta-model standard through the convergence of these different approaches. So what Vitek has done to try to move in that direction is we have all the SysML version 1.5 diagrams already mapped on top of the systems meta-model. As you saw in the exercise today of generating our project demo, we were utilizing block definition diagram, internal block diagram, activity diagrams, and also associating those with some of the more conventional diagrams and representations that systems engineers have used over time. So you can start today and start building out conformant representations, version 1.5 conformant representations, on top of the systems meta-model and gaining all the benefits of the explicit relationships and guiding the commonality of practice and guaranteed synchronization between all your representations because it's all implemented in data. So you can start doing that today. And in that way, you can start future-proofing your path to SysML version 2. Now, what Vitek is doing in their involvement with the standards body is to try to maintain a mapping of all of these explicit relationships between the origin and target classes as they're expressed in the systems meta-model and track how the SysML v2 language is evolving. So in doing so, we can build up a prototype version of Genesis that actually has that schema in place in it, and you can start to model as the the months roll by. It's still early, but as we continue to maintain this, we can associate the models that you're doing today at the SysML version 1.5 level, and be assured you'll be able to transform them into SysML version 2 as it stabilizes and becomes available in the next 2 years. So there's a number of discussions going on about what the best way is going to be to migrate the current SysML models that are out in existence and in operation into SysML version 2, because v2 is trying to be meta-model based. It's applying modern database technologies through web interfaces and common API. It's all part of the requirements for the new standard. So that is going to give us a lot of the system meta-model underpinning capability of being explicitly represented data in a repository that's accessible from many types of views and representations and tool types. So the vision is clear, and we need to get there, but how we maintain the value of the investments we're making is going to require us to be cognizant of the path we're taking to get there. So that's how Vitek is trying to help with that. So in summary, we think the concurrent and consistent form of systems engineering that we're going to need as we move into the future is available now. And you can chart a path forward to the developing standards that are we're hoping will help support enterprises to realize MBSE 2.0 performance. Thank you very much. And Donna, with that, I'll take any questions that may have arisen.
Thank you, Mark. We do have a few questions, thanks to all our participants. I encourage you to join the discussion now and submit your questions using the webinar control panel. If you do need to leave the webinar, please take a moment before you go to respond to the quick survey that will pop up on your screen. Our first question comes from Amy. Can the explicit relationships of the systems meta-model enable behavioral simulation?
Oh, that's a good question. Yeah, the simulation was a bit deeper than we could go today in the time available. We're looking at that for a future webinar topic, but because the behaviors are also explicitly represented in the relationships to describe activities and enhance functional flows. They're completely simulatable. Genesis has a discrete event simulation built into it, so as you're building out your behavioral architecture, you can rest assured that that behavioral architecture will be completely simulatable.
Thank you. Okay, another question from Jennifer. Can you track the results of testing and how they affect and trace back to system requirements and design?
Absolutely. I skipped over some of the detail on that just for sake of time, but as we described in the V&V portion of the systems metamodel, how a verification event is, how it employs different test configurations and procedures, as well as how those verification events are executed by the different test activities. All of that provides an explicit traceable path to the verification requirement, and when that verification requirement is fulfilled, that fulfills the source or derived level, leaf level requirement that it's associated with. So that's a very strong part of our methodology, and we'll assure that traceability.
Okay. We do have another question from Doug. The question is, will Vitek support a user experimenting with the SysML v2 prototype?
Yes, that's our intention. As I mentioned, it's still a bit early in that work, but we do have the intention to continue to track a prototype version of Genesis for the SysML v2 schema. And as that becomes complete enough that you can actually do modeling, and it's becoming close. I mean, there is a prototype of the textual notation of SysML v2 running recently. It's been publicly announced just a few weeks ago. So we're getting close to the point that we can actually start doing that work, and it is our intention to support any user that wants to evaluate and start to describe their path forward.
Okay, thanks, Mark. That wraps up the final Q&A for today's presentation. If you have any other questions or comments, please don't hesitate to send us an email, or you can post your questions and comments on our LinkedIn group page. Just visit linkedin.com and search for Vitek Corporation. Thank you so much for attending today's webinar. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.